Third form, we are doing a little experiment today where we've got two powders and we're going to react them together. So in here is copper oxide, and it just looks like soot. But the reason why it looks like soot is because the copper is bonded to the oxygen, so it doesn't look like normal copper metal. It's quite hard to get it out of the jar. I'll just get a good taste of this into the test tube. And the other chemical that I'm going to put with it is carbon. And so this is actually soot, and this is the element carbon. What we're going to try and do is a little experiment where the carbon steals away the oxygen from the copper. So the copper oxide and the carbon are now in the test tube, and it doesn't look like much, it's black powders. But we're going to heat them, and we're going to see if the copper oxide will lose its oxygen to the carbon. Now, the reason why that might happen is if the carbon is more reactive than the copper. And so carbon is a non-metal. Up to now we've been looking at metal reactivity series, but carbon's a non-metal. And we know, just let you into a secret, that carbon is more reactive than copper, and so it should be able to steal the oxygen away from the copper. And if that happens, we should see little flecks of pure copper forming in the test tube. So the next wee part of the video, you're going to see the Bunsen burner really heating this test tube strongly, and we're going to see if we've got any evidence of reaction taking place. So third form, what we've done now is I've put the test tube, plugged it in at an angle and pointing away from me, and I'm heating it really strongly with the Bunsen burner. And in chemistry, if a reaction's taking place, you often see heat being produced. And although I'm actually heating it, there's a little red glow at the very bottom, and that is coming partly because it's being heated, but also because it's actually doing a chemical reaction. And so I hope you can see that at the bottom, it's really glowing red hot, and that's because the carbon is now stealing the oxygen away from the copper, so a chemical reaction is taking place. I'm going to lift the Bunsen. This isn't something we would always do, but I just want to get it really heating at the side here as well, on the back. Just really heating it from all angles so that it really gets red hot, so that it can have an opportunity to do its reaction. And then at the end, we should see little flecks of copper. I'll just go from beneath again, get it nice and hot. The hottest part of the Bunsen flame is just above the middle blue cone. So when we have the air hole fully open, you can see that wee blue cone, and it's just above that is the hottest part. So if I get this heated again, really hot, and you should see that it is glowing. And as well as that, then at the end we should be able to see little flecks of red, brown copper forming. So third form, I'm now going to tip out the contents of the test tube. I'm holding it still in the clamp because it's going to be really hot. I don't want to burn myself. So if we tip this out onto this watch glass, and when we do this, it looks a little bit, it's like digging for, well, it's not gold, it's copper. But I'm going to use the spatula. I can see little flecks of red, brown copper in that. It might be hard enough for you to see it. I'm going to shake this to see if we can get any big lumps to come to the top. And so probably quite hard for you to see, but the colour of this to me is now looking much more red-brown. So there's still a lot of black carbon because I put in lots. We say that's being using a reagent in excess, so I put in loads. And the copper that's forming is just where my spatula is pointing. And so you would need to do further separation, use your separation techniques to try and get that copper out. And maybe heating it up again and really making it molten to try and separate the copper. But the copper's definitely there. The powders now are not as black. So if you're kind of just trying to see that, we haven't got a massive big lump of copper. We've got little flecks of copper throughout our mixture. And that's what's making it look not so black anymore.
Just to explain then what we want you to do for the rest of the lesson. So first of all, if you read through and complete the rest of page 18, filling in any gaps that you need to, just try your best. If there's anything you're not sure about, you can leave that out for now. Then we want you to read through the top of page 19. just up to the point where it starts to explain the research task of the production of iron. We'll leave that to a later lesson. And then we want you to answer summary questions 7 to 9, so 7, 8 and 9, which are on pages 30 to 31. Then once you have those tasks complete, please mark your work from today using the answers provided. It's important that you give the work a go yourself first before looking at the answers. So use the answers simply to mark your work and add in any corrections, and do that in a different coloured pen. Then please upload a photo of your marked questions 7 to 9, that's the summary questions, to the assignment on Teams so that we can see you're keeping up with the work. So just a simple photo of the questions 7 to 9 at the back of the booklet, and make sure those are marked before you submit them.